Assalamu alaikum. Today the topic of our algorithm project is dynamic perfect hashing. Dynamic perfect hashing is an algorithm we use for making a dynamic hash table. The idea of dynamic perfect hashing was first invented by Edward A. Fox, Chi Fan Chen, and Amjad M. Daud in 1984. They proposed extendable hashing with dynamic overflow, which was one of the earliest dynamic perfect hashing algorithms. Dietrich implemented a dynamic dictionary algorithm on the basis of dynamic perfect hashing in 1994. Dynamic perfect hashing is a method of programming in a hash table data structure for resolving collision by constructing a perfect hash function for a set of keys that can be updated dynamically. Keys can be added or deleted from the set of elements without having to rebuild the entire hash function. Real-life use of dynamic perfect hashing is in cloud storage. In cloud storage, the cloud providers use dynamic hash function for the counting of the duplicate data and also for the security purpose. As the increasing demand of data rates, cloud storage system has become a necessity for computer users. But in cloud storage, many users upload same type of data like a popular movie, song, research paper, etc. This causes the use of cloud storage inefficient. So the cloud storage providers use data deduplication. Data deduplication is the process of removing duplicate data from the cloud storage. It helps to keep the track of popular or unpopular data, and it makes the counting of the duplicate data easier. It is useful for retrieval of data in a constant time. It makes the data layer more secure in cloud storage because it was the two-level hashing. Now we are going to explore the flowchart of dynamic perfect hashing. Start, insert data. Count is the variable where we keep the number of data of in a table. So we are increasing the count by 1 because one data is going inserted in the table. Then if count is bigger than the size of the table, so if yes, we will rehash the full data set. If table equals to 0, yes, we will do the second level hashing and we'll keep the hash in k. If we'll create a set of 4 elements, clash and pop t. Pop and t are the arrays, clash is the collision handler, and is the number of elements in the main table. We will insert the data in the secondary table t and will increase the same index in the another array pop that is initially 0 by all. We will increase that 1 in the same index. Index j is not equals to 0. We'll do the second level hashing and keep the hash function in k. We'll check if the k index in the t subarray is empty or not. If yes, we will insert the data in the subarray index k. The data in the index k in subarray t is equals to the inputted data. If no, that means there is a collision, and we will increase the clash by 1. If clash is greater than or equals to 1, we will double the size of the array t and rehash the array t using a randomized perfect hash function, and we will use a temporary list or array L for the help. If any element remains in the L, that means there is still collision, so we will rehash the full function again. Now we will see an example of data deduplication using dynamic perfect hashing. Here we have 4 data, 2, 3, 2, 14. We have a primary level hash function hash1. For the primary level hashing, we get the index number to place our data. Then on that position we are creating a set of 4 elements. The 4 elements are clash, which is the collision handler, initially 0, number of elements, which counts the number of elements in the subarray tree, and which is initially 0, pop, which is the popularity count or duplicate count, and which is initially 0 for all indexes, and t is the storage or the subarray we will put our data in. Now from secondary level hashing, the index of sub array, we will keep the data. After keeping the data, we will increase the popularity count by 1. From the first level hashing, we get 2. So we in the index 2, we create a set. After the second level hashing, we get 1, and in the subarray tree, in the position 1 or index 1, we will keep our data 2, which is 2 in that position, and in the same position of popularity count, which was initially 0 for all indexes, we will increase 1 in the popularity count for the same position or index. And for the second data tree, we will do the same thing. First of all, we will do a primary hashing, and we will find out the main table part, and second of all, we will do the secondary level hashing, and we will put our data in that. So 3 will be in the primary level hashing in 0 index, and the for second level hashing, it will be in the second index or number 2 index in the T, and the popularity count of the number 2 will be 1. And now we have a repeated or duplicate data. So here we will see how dynamic perfect hashing helps us in data deduplication for cloud storage. For 2, we get 2 more 2 3, and for hash primary level hashing, and for secondary level hashing, we get 1, and we can see that the data is already present in the sub array tree. So the our algorithm will increase the popularity by 1, so that we can keep a track how many number of duplicates of the data are in the cloud storage. If there are 10 number, if a data has a 10 number of duplicates, then the data is a popular, or we can easily conclude that and find out which data is popular and which data is not popular. And this uses of dynamic perfect hashing also secure the data. Because of the two level hashing, an attacker can't enter in the storage and retrieve your data, because he need to pass the two level hashing. And for 14, we will see now what. For 14, the first primary hashing is index 2, and the secondary hashing is in the subarray index 1. As the subarray index 1, there is a element 2, and our algorithm will check if 2 and 14 are same element. If that was same element, will increase the popularity count by 1, but they are not the same element, and a collision is happening. So what we will do, we are going to use a temporary array L, and we will put our all the elements of T in the L. So there are two duplicates of T2 in the array T. So in the L, we will keep 2 2, and we will keep our mm, new data 14. We will double the size of T array, and we will also double the size of our popularity count array, and we will use a randomized hash function and to put the data from our temporary array to our sub array. And first of all, we are using 2 mod 5 2, so we'll input 2, and we will increase the same index by 1. And second of all, we will increase the same index by 1, because there are two twos, so duplicates. And for 14, the randomized hash function is 4, and we'll put 14 in number 4 index, and in popularity count we'll increase number 4 by 1 from 0 to 1. Let's start with the flowchart for popular data finding. If we start, the flowchart will look up for a key, and it will use the key for primary level hashing and secondary level hashing. Then it will find the primary level hashing in the index. If the index of that table is none, then there is no data, so the data you are watching for is unpopular. If it is not none, then the secondary level hashing will be used for the secondary sub array. If in that sub array, if popularity count is 0, then data is unpopular. If it is not 0, then there is a data and it has duplicates. But if the data count is equals to or greater than z. Z is a term we use for popularity. If z equals to 10 and your data deduplicates are 10, so your data is a popular. Thus, while using dynamic perfect hashing in data deduplication is very useful, but there is no unmixed blessing on earth. The rehash in this process takes big of n times, which is more costly, and it also uses a temporary array, which is also costly. And this algorithm is very complex. And that's all. Thank you so much.